Okay, let's get started. Hello, everyone. My name is Yaron Schneider, GitHub handle Yaron2. Today, I'll be substituting for Mark Fussell. And yeah, I hope I'm going to do a good job and be your host. So let's get started. As always, we'll have time for questions, and we have quite of a packed agenda today. So let's go on, and I'll start sharing my screen. Okay, I hope everyone can see my screen. Please, somebody say something if you can.
Looks good.
Yeah, okay, good, thanks. So today we're gonna be welcoming you, which I think I did, and then I'll be talking briefly about our latest release, 0.5.0. And then we're gonna see a demonstration of Ingress on Kubernetes with Dapr with end-to-end encryption from Yaron Schneider, which is me. And then multi-cloud secrets API with a component authorization, me as well. And then we're going to have Aman and Leon show us the new and improved .NET client. And then we're going to kick it over to Youngbu and Shalab, and they're going to show us awesome new matrix, mainly for you ops people out there. And then we're going to let Mark take it in with 0.6.0 and share maybe a few more things that we're doing alongside Dapr and service meshes. So let's start with Nginx and Ingress on Kubernetes. Let me open up my slide here. This really basic slide. And a question that we've been getting a lot is from people is, I understand how to direct traffic inside my cluster from one service to another, but how do I direct external traffic into my cluster? And how do I have it be encrypted end to end? So if we take a look at some Ingress implementation that you have here, and it can be Nginx, it can be traffic, it can be an Istio gateway, you would basically set up a TLS termination for the layer 7 load balancer here, and then you would direct traffic into your application. And in order to have end-to-end encryption, you'd probably need to set up some TLS termination on your app as well, or you might have the traffic itself in the cluster be unencrypted because you trust the network boundary of the cluster. But in zero trust networks, we're basically saying, hey, you know what? We want end-to-end encryption inside our cluster. And well, that's all good and working for inter-cluster communications. How do we can really drive this end-to-end? So what if we could basically do something like this? What if we could take Nginx and not only Dapprize our application, but actually inject Dapr into the Nginx controller or traffic or HA proxy? So think about your Ingress controller that is in itself Daprized. And then that's Daprized.
This is not going to work with application gateway, right? Application gateway Ingress controller.
Yeah, okay. I'll finish this and I'll answer about application gateway when we're done, okay? Keep that question. I'm going to finish this, and then I'm going to talk specifically about application gateway and how this is going to work with app gateway. So this ingress also, by the way, can be application gateway running in a container. So think Nginx traffic, HA proxy, just insert your Ingress controller here, and then we Dapprize it with a Dapr container. And then what we can basically do is, because that Ingress controller has been injected with Dapr, all communications coming in from the outside will get TLS terminated at the Ingress level. And then if it needs to talk to a Dapr service inside our cluster, that will basically be able to kick off MTLS with Dapr and provide end-to-end encryption. And they can also use the same encryption keys, or they can use different ones. So we've been thinking, well, can we actually do this? Can we Dapprize something that's not in our control, like an app that we don't control? Just inject the sidecar there and hope that it works. Maybe like a service mesh. And well, the answer was yes. So what I'm about to show you now is a demo of how this is working, and then we can open it up for questions. So I'm really going to take it from the tops, and we're basically going to see everything. I'm not going to leave any stone unturned here. And that's because I want to be very clear about what we're doing. Even going to show the non-Dapr steps that we're going to do. So what I'm going to start with is by deploying Nginx. And first of all, I want to establish a TLS secret for TLS termination. So what I will do here is basically just create an OpenSSL key. So this is a command line for creating a certificate with the host name of Snoke, right? So this will basically create a certificate that's valid for a year with the key and insert, nothing special here. And we can see that the private key and certificate have been written successfully. And then the next step is to create a Kubernetes secret off of those certificate and key. So I'm telling Kubernetes, hey, create me a TLS secret named TLS secret using the key and the certificate that I've just generated. So we're going to go ahead and create this, and we can see that the TLS secret has been created. And now the next step is to deploy Nginx, but we actually need to inject Dapr inside of Nginx. So for those of you who don't know, the way to inject Dapr in Kubernetes is by annotating the deployment YAML with a few annotations for Dapr, which tells the Dapr operator running in the cluster that it needs to inject the sidecar. So what I have here is the Helm chart for Nginx Ingress. And what I can do here is basically go to the values, and I've taken these pod annotations here, and I've Daprized Nginx. So I enabled Dapr, and given Dapr the Nginx port, and given the Dapr sidecar, which is going to be running with Nginx, the ID of Nginx. Pretty straightforward. So if we go back here, and we're going to go into Nginx Ingress, I can just do helm install Nginx. And this is running. So this is creating. We're going to wait for it to be running. And we can already see that one of the two containers is ready. I'll bet you it's Dapr. Nginx takes just a little while longer. And now we have Nginx controller running, and we can see that Dapr was injected inside the Nginx controller. So everything seems to be in order so far. We have Nginx running with Dapr. And the next thing to do is to create the Ingress route. So this is, so far, there was nothing Dapr related here other than specifying those annotations. I created a Kubernetes secret for a TLS, and then I deployed Nginx. So the next thing, which is a Kubernetes specific construct, is something which is called an Ingress route. And this Ingress rule is basically telling, hey, any traffic that comes from a host of Snoke is going to be TLS terminated with a secret, with a certificate that's being kept in the TLS secret. And that's the secret that I created prior. And I'm basically just having a pretty simple path here. So anything that comes for / and service name Nginx Dapr with port 80 is going to basically hit Nginx Dapr. So any request that comes in is going to hit Nginx Dapr, which is the Dapr-enabled service for Nginx. And now to understand what that thing is, when we Daprized Nginx, if we take a look at the Kubernetes services, we can see that Dapr created a service called Nginx Dapr, which is the service that would route traffic that's coming into Nginx into its local Dapr sidecar. And if you think this is going over the network, then, well, you're wrong, because Kubernetes services are essentially IP table rules. So when Nginx is gonna route the traffic to Nginx Dapr, it's basically gonna hit the IP table rule inside the node, and that's basically gonna reroute it inside the pod to the Dapr instance that's running there. So all this seems to be working, and the only thing that I'm left to do is apply the Ingress YAML here. So I'm gonna go here and apply Ingress. So we can see that the Nginx Ingress YAML has been created. And basically what we have now is this. We deployed Nginx, we have Dapr running here, and we have this Ingress YAML telling every request that comes to slash with a host of Snoke to have TLS termination with the secret that we did. And then the traffic will be routed to the local Dapr sidecar running inside of the Nginx pod. So I think there are a few people waiting in the admission. Let me see if I can admit them. Yeah, all right, 3 people waiting. Okay, let's go back to our demo. So we have all that running, and what we're going to take a look at now is the public IP for the Nginx controller. So for the purpose of our demo, we have the widely used, famously known distributed calculator example. For those of you who don't know what the distributed calculator is, it's basically an application that comprises of 5 microservices with a calculator front end that does division, multiplication, subtraction, and adding through discrete microservices. So we have add written in Go, we have divide written in JavaScript, multiply written in Python, and subtract written in C#. And you can see I've demoed this so much that I actually remember with what language each service is written at. So we're going to try and basically reach our Ingress controller from the outside and reach this divide app microservice here. And we want to see that our Ingress controller is able to actually direct the call to the Dapr instance that's running the service, and that we get MTLS enabled all the way through. So let's open Postman here, and I'll just zoom in a bit. So we have this URL here, and this is going to be calling, and I will just take this external IP again and replace it with the one here. So we will be calling our external IP, and that call will reach our Nginx ingress, and we're calling the invoke endpoint for Dapr, which is what you use for service discovery. And we're basically telling Dapr, hey, reach the divide app microservice running in my cluster and invoke the method divide. And this is the JSON that I'm giving it. So I'm basically dividing 9 and 3. So I'm going to get 3 as a response if everything runs correctly. And if we look at the headers, I created the Snoke header, and I'm using HTTPS to verify that we actually get SSL termination on the Nginx ingress. So let's do that. And we see that it worked. We got a response back, which is great. So we basically just issued a command which reached from the public internet to the Nginx ingress that instead of routing anywhere in the cluster, that got routed to the Dapr instance running inside of Nginx. And then Dapr MTLS took the call and secured it with in-transit encryption using Dapr MTLS to the divide application that was running here. So this is a way for you to be able to basically expose Dapr APIs through Ingress. And of course, by your choice of Ingress controller, you can choose to expose only some of the Dapr APIs, right? And enable some regular expression-based routing rules or your own routing rules or whatever you need. So this is it. And just to make sure that we had MTLS running all the way through, let's go ahead and look at the logs for our divide app. And I think the container name is divide app. Let's take a look here. So it's divide. Oh, right. This is, yeah, we should take a look at Dapr, not the divide app. And if we go here, we can see that MTLS is indeed enabled, so we had end-to-end encryption. And by the way, those are the new Dapr logs. They're quite more verbose than they used to be. Yeah. All right. So before we move on, questions, let's take a look at the chat. This is so cool. Yes, it is. Thank you. The tricky ones to do this with AGIC. What's AGIC? Application Gateway Ingress Controller? Yeah, so, well, it was obvious, actually, and that's the great thing about it, because when people asked us, how they could do this, it actually took me less than 10 minutes to get this running. And seeing that Dapr can naturally, be injected into other infrastructure components that we don't necessarily support is great, because it means that Dapr can run alongside other solutions, and you don't have to always just configure your app to use it. And via means of configuration, you can have Dapr integrate with whatever infrastructure that you're running in. So the fact that it was obvious, I think that's pretty great. And about Azure Application Gateway Ingress Controller. We haven't tried that. I think it should be fairly simple. To be honest, I haven't seen the container for Azure Application Gateway.
But let me tell where the problem is.
Yeah.
The problem with Application Gateway Ingress Controller is that this Ingress Controller is like an application gateway deployed outside of the service mesh. So outside of the Kubernetes. So it has a different IP address range. It's not hosted on the nodes. The only thing that are hosted on the nodes is a controller plane, management plane, that whenever it detects an ingress resource, like the one for Nginx, it creates rules on the application gateway ingress control, on the application gateway, right?
Yep. Mm-hmm.
So this works pretty much different. And the problem is that you cannot run sidecars on application gateway, right?
If you're running it on Kubernetes, wouldn't it just be a Kubernetes deployment?
No, the problem is that the actual ingress, like the actual gateway is running outside of the Kubernetes.
Yeah, okay.
So if you run a pod, it's like, it's not, the only thing running on the Kubernetes is the management plane for the ingress controller, for the application gateway.
Yeah, so that's a little bit of a weird architecture. From what we see, the common way to run Ingress inside of Kubernetes is have the Ingress controller inside of Kubernetes. What you want to do in the application gateway, and granted, I haven't tried this.
But this one is going to be preferred solution by Microsoft, as I observe. It will be integrated like in AKS out of the box, and this is why I'm asking those questions.
So Marcin, is it the scenario of APIM? Is it the scenario of APIM which you're talking about?
No, it's a. I will send some links in several minutes so you can see.
Yeah.
Okay.
Yeah. So specifically, this is for Ingress controllers they're running inside the cluster. We're going to have to see how Application Gateway does it. From thinking about it, you might have it basically routing the requests to a controller inside the cluster, and then you would Dapprize that thing. But in any case, even if it's running outside the cluster and you're having the TLS termination there, there might be a way, depending on how it routes the traffic inside the cluster, to route it specifically to a Dapr service running inside the cluster. So that might work. And okay, so we'll take a look at the application gateway for Kubernetes, and we can bring it up in the next community call about how to do this with application gateway. Yeah. And yes, Mark Fussell is right. You can get AGIC to talk to Nginx or traffic or an Istio gateway. And then Kevin Harris is asking, what is the benefit using Dapr for MTLS in this case versus service mesh? So if you only need Dapr functionality here, there's no reason for you to use a service mesh really, because Dapr basically gives you this MTLS functionality. If you're using a service mesh for something else, well then you can basically turn off MTLS in your service mesh and still get all of the observability capabilities that you get with the mesh, and then use Dapr for its capabilities. Or, right, you can do exactly what I showed you here. You can disable MTLS in Dapr and then enable MTLS in the mesh, and then use Dapr for all of its APIs and utilize your mesh for the specific in-transit encryption that you're using.
So I have pasted 3 links for you. First one is the general project of Application Gateway Ingress Controller. Second one is the architecture diagram that depicts the how it looks like. And the third one is the issue on AKS roadmap that mentions that this solution will be integrated in AKS out of the box. So it will be the preferred ingress controller in Azure.
Okay, yeah, sure. I mean, we can.
Yeah. I think the answer is that we'll investigate this one now, Marcin. Yeah, you're right. We just wanted to kick this one off. This is Mark Fussell speaking here on Nginx to show what's possible. But you're right. We'll look at this one, a GIC next.
Yeah.
Awesome, thanks.
Yeah,
Thank you very much. I appreciate it.
All right, so this is what you can do.
So Mark, Yaron, it's Kevin here. Just on that service mesh piece, just looking for guidance around that MTLS. So if I understand that correctly, then in that process, so if I have an existing service mesh, I've already got MTLS between different services. So if I ingress a request, and just like you did there, coming into Nginx or whichever ingress controller is accordingly, would I still run that Dapr sidecar on that Nginx ingress controller, or would I just have that on my workload pod?
Yeah, you would still run the Nginx, the Dapr sidecar there. You would just not be using Dapr MTLS. So you would want basically every request that comes to Dapr from the outside to hit the local Dapr endpoint to distribute traffic. So you'd need to Daprize your gateway. For example, if you're using Istio, it would be the Istio gateway. And then you would disable MTLS on Dapr and just use Istio's MTLS or Linkerd's MTLS.
So, but why, I guess, just speaking architecturally, so why would I go through the process of putting that, again, yet another sidecar on my ingress controller versus just, again, hitting that Daprized endpoint on my workload? Like, why do I have to go from ingress controller pod to sidecar, and then from sidecar over to another Dapr sidecar, and then actually into my workload? Like, couldn't I just remove an actual hop in there and a piece of complexity? I guess that was kind of more my question around the service mesh, like in terms of guidance we give to customers. So if somebody's using a service mesh, are we recommending to put a Dapr sidecar then on every single workload inside the cluster?
If you're already using, yeah, if you're using a service mesh, so it depends, right? First of all, you could remove it and then create specific service endpoints to point to specific Dapr endpoints. So for example, if you had 3 microservices running and you would remove the Dapr sidecar from the ingress, you would need to create 3 routing rules, right? For different endpoints coming into your cluster. So the number of configurations that you need to apply for each Dapr-enabled microservice would basically grow with each new microservice. By using a Dapr sidecar there, you would basically be letting the Dapr sidecar in the service mesh pod route the traffic on your behalf. So you would basically only have one configuration saying for every incoming call, route the traffic to my local Dapr instance, and that would basically decide where the traffic goes, because Dapr instances, Dapr sidecars know which pod needs to get the traffic. If you're just doing that with the service mesh without having the Dapr sidecar running there, you'd basically need to handcraft the service routes that take a request for one specific service and send it over to a different one, which would, basically also be cost performance, because that's going to be using the service mesh that you're using, it's going to be creating IP table rules on your host, etc. And then another reason why you'd want to have Dapr there is because of distributed tracing. So,
okay,
yeah,
those are good points on that. So I'm just thinking here from like putting a little bit of a security hat on then. So how do I then lock down coming in then from ingress? So if I've just put a Dapr sidecar on my ingress controller and I'm basically saying I can get to any Dapr service inside the cluster, so to speak, how do I lock that down from a security perspective? So I'm managing my routing in Dapr versus managing my routing in ingress controller. So I think that's, again, whether you're going to be more of a app dev centric person or whether you're going to be more of a infrastructure ops person. Again, pros and cons to both of those. But if I put a security hat on, how do I then say, okay, this ingress controller, I want to make sure it can only reach, let's just say there's 10 services. I want to make sure it can only reach 5 of those services. But right now it sounds like I could reach any service that has a Dapr sidecar on, or sorry, yeah, I guess anything that's has a Dapr sidecar on it.
Yes, so for that specific thing, that's where Service Mesh can help you, because you can still have the Dapr sidecar sitting there. And then instead of, for example, instead of creating separate endpoints for every service that you have in your cluster, you can use something like, again, Istio. If you're using Istio policies, you can basically blacklist some of those services for pod-to-pod communications, because you also have Envoy running there. So it's basically a matter of blacklisting instead of whitelisting, really. Does that make sense?
Yeah, it does. So I still
Okay.
have just essentially one ingress rule, so to speak, from my ingress controller to talk to that
Yes.
sidecar. And then that sidecar has all the routes, but then in that case, a service mesh policy, or it could be like a network policy or something like that, would then govern what can actually talk to what.
Exactly. Yeah.
Okay.
All right. Great. All right. So if we have no more questions, do we? Service Mesh does not work with Windows nodes yet. I guess that's true. Yeah, if anyone has any more knowledge regarding this, they can educate us all. All right, so let's go back to our agenda and let's see what's next. So multi-cloud secrets API with granular component authorization. Okay, so we had the 0.5 release, which, by the way, and I'm going to take a short break just to talk a little bit about that. The 0.5 release was released 5 days ago. You can go ahead and get started with it. Some of the things we put in are authorization for components, a new secrets API to get a hold of your application secrets, not just your component secrets. And then we also put in some pretty comprehensive matrix for Dapr runtimes, which we're going to be showcasing later on. That's going to show you how to get things like request latencies and throughput and a bunch of other stuff that's just going to raise some more questions about service mesh matrix and Dapr matrix, really. So check out all those things. The how-to section is a really good place to basically come in and learn how to use all those new capabilities. The how-to section, by the way, and this is a general guidance or suggestion, is something that you want to take a look at pretty closely, because I think it's a part of our docs which we probably update the most. And then up until 1.0, you'll see a lot of breaking changes. So go ahead and look at all those breaking changes if you're upgrading Dapr. If you're doing something like running Dapr in a production environment, then this is really important for you. So this has been Dapr 0.5, and I've talked about the ability to scope components. So what we heard from a lot of people was that, I have 2 state stores and I have 3 applications, but I don't want all of those applications to be able to talk to that specific state store. Or, I have a bunch of bindings, so I don't want all of my applications to be able to load the, I don't know, AWS SQS binding and get events from it, because first of all, my developers could mistake routes, and then they would start getting notified about events where they shouldn't be, or that would basically, from terms of security, it would allow for a greater attack surface. So we've listened to that, and we introduced 2 new security capabilities in the 0.5 release. The first is the ability to limit components for namespaces. And let's take a look at the admission here. Yeah, people are still joining. Okay. So the ability to namespace a component is basically looking like this. And I'm going to switch over here to the multi-secrets component. And today we're going to be looking at Go and Python. We showed the secrets API in the last call, and we showed Rust, and people have been asking for non-Rust languages for secrets API, like more prevalent languages. So we listened and we didn't show Go and Python pretty recently. By the way, if you guys want to see more languages, feel free to write to us, whether if it's on GitHub, or right here in the chat window if you'd like to see us providing more samples or examples with the language of your choice. We'd be happy to. All right, so let's take a look at my Python application here. And this Python app is going to be getting application level secrets from Azure Key Vault. So I have my secret store using Azure Key Vault, and I have my vault name, my client ID and tenant ID. And then it's configured to take the certificate from a certificate that I'm running inside my Kubernetes cluster. So I have a secret inside of Kubernetes called Key Vault, which has the certificate inside, and this secret is already there. So if we do kubectl get secrets, I can already see that we have Key Vault here. All right, so and then this specific component is gonna be used by this Python application. Similarly, I have a Go application which will be taking its secrets from an AWS Secret Manager secret store, which we've released alongside GCP Secret Manager in the 0.5 release, and the session token is here along with the region. And I'm taking the access key and access secret for my AWS credentials, again, from a secret inside of my Kubernetes cluster to be able to authenticate with those secret stores. So on Azure, on AKS, Azure Key Vault with Dapr supports managed identities. So I'm not using managed identities here just because it's a little bit of a pain to set up. So I'm just using the SPNs as a Kubernetes secret. Yeah, for brevity. So this is basically what you guys know. This is how to set up a state store. And really calling the application secrets API is as simple as this, right? We basically issue a GET request for secrets for Azure, and we're basically telling Dapr, hey, go to the Azure secret store and grab my secret, and then print it. Similarly, for Go, we're reaching to the same API and asking for the AWS Secret Manager to return us the secret, my secret, and then printing it. So I have all those code bases pushed into a container YAML. And here we have the deployment YAML, nothing special here. This is the deployment for Go. So we give it an ID of Go secret with the container that's running this, and also for the Python application, a regular Kubernetes YAML with the ID of Python secret. So let's take a look at application level scoping now. Let's say that I want my Azure Key Vault store to only be accessible by my Python application. So remember, I have the Dapr ID of Python secret here, and the only thing I need to do is basically just input scopes, and then input the name of the Python secret here, and that's it. And we're going to take a look at that in action. In terms of namespacing, for example, if that component was deployed into, let's say, namespace Lala, and my application would be in the default namespace, my application would not be able to grab hold of that component, even if I scoped it. So let's remove this. And we have more people, I think. Oh, chat window. Nice implementation, thank you. All right. Okay, so we basically just scope the Azure Key Vault to the Python secret app, and the AWS Secret Manager app is not scoped. So we'll just leave it at that. And what I'm going to do here is basically go to deploy, and I'm just going to apply the Azure Secret Store. And I'm going to go here to my Go application and deploy the AWS Secret Store. And we're going to run the Azure one first. So I'm going to be deploying the application. And if we go here, we can see that the container is running. And we can take the logs. What's the name of my container? Let's take a look. It's app. All right, that's pretty simple. And we get the secret, and the secret is an Edgar Allan Poe song. So if we go to Azure Key Vault and we look here, this is the secret called my secret, and we show the secret value. This is the secret itself. So now we'll go ahead and deploy the AWS one. Now, I'm just saying in advance, there is a possibility that this won't work because my AWS session token has expired. So let's see. All right, so we have the Go secret running here. And yes, looks like this is running. And this is the secret that's getting extracted by my application through Dapr from the AWS Secret Manager, another Edgar Allan Poe quote. And what we're going to do now is basically test the scoping mechanism that we saw. So I'm basically going to assume, let's say, the role of an attacker. And I'm going to port forward to my Python application, which is using this secret store. And I'm basically going to try to invoke the other secret store here. So yeah, let's do that. First of all, are there any more questions before I deep dive into this? All right, not currently. So again, we scoped the Azure Key Vault for the Python secret application. And so we're going to be port forwarding to my Go app. And I'm going to give it 3500, 3500. All right, so we got the port forwarding running. And now I'll just zoom that in a little bit. I will curl. So now I'm going to call the Dapr endpoint on the Go microservice, telling it to grab me the secrets for the Azure Key Store. And we can see that we get an error code saying the secret store was not found. And it's not found because we basically scoped this secret store to the Python application. And what's really nice about this is that the scopes work for all components. So if you think about it, you can scope state stores, you can scope pub subs, you can even scope HTTP middlewares or tracing components or matrix exporters. Anything that is a Dapr component can basically be scoped to an application or to a namespace. So you can scope secret stores as basically just as well as any other component that exists today. And any new component that will be implemented in the future will already make use of this scoping feature. Okay, so that's it for this feature here. Let's go back to our agenda. Okay, the next thing we're going to show is the improved .NET Client API. So I'm going to hand this over to Aman. Aman, take it away.
Hey, Jeroen, just as a little update, is there anyone waiting in the room to join? Because you as the host, you have to let them in.
I made sure to look at the admission list. Currently, no one's waiting.
Okay.
So Jeroen, for the .NET, Leon would be doing the demos today. So
all right, great.
I'll let Leon take over.
Yep, Leon, go ahead. I think you're muted, Leon.
Can you hear me now? Hello?
Yeah, we can hear you loud and clear.
Okay, sorry, I was muted in two places. Can you see the screen?
Yes.
Indeed, we can.
Okay. Okay, sorry about the delay. So in 0.5, we added more APIs to the .NET SDK for PubSub, service authentication, state management, and bindings. I'll be showing a quick demo here of two of them. So right here, what I'm going to run is a .NET app that will send that will invoke another service. In this case, it'll be a service with the name node app with the method hello, and it'll just send some custom data, and it'll get something back. In this case, the other app is a node app. So if I start a node app here, And now it's running. Now run on the left side, the .NET side. You should see it get something. So the first part here, so I actually ran two parts, but the first part here, it got the method, got the message right here, and it returned a string, which in this case is cat. In the second part, which I didn't introduce yet, but I already ran, we had it invoke, we had the .NET SDK invoke a binding. In this case, a binding has a name sample123, and again is just custom data. And we already saw it appear down here on the Node app side. So that's just a really quick demo of two of the types of APIs you've added to the .NET SDK. That's it.
All right, thank you, Leon.
I want to add the changes which we have made to the .NET SDK. So earlier, folks who have used the .NET SDK, they might know that there were APIs for state management and for invocation, but they were going over HTTP, and you had to create individual clients for each one of those clients. With the changes done in 5.0, you don't need to create multiple clients for performing those operations. You just create one client called Dapr client, and it has APIs to perform all the operations with the Dapr sidecar. The changes also include that these calls now go over gRPC, so it makes them more performant. Since they use the auto-generated bindings, auto-generated SDK from the protofiles, and we have introduced these wrappers which call onto those auto-generated APIs under the hood. So that's the whole explanation of the improvements we have done to the .NET Client APIs, and Leon showed the demo for those APIs. That's all, Leon.
Okay. Great, thanks. So next up, I think can you guys hear me? Yeah. All right, and next up are Youngbu and Shalab, who are going to show us the advanced matrix. Kicked away.
Shalaf, can you start with the systems dashboards first?
Hi everyone, can you see my screen?
Yeah, we can see your
Yep.
screen and we hear you.
Yeah, okay, good. So thanks. In this release, we have added observability into the Dapr system, and we have added a bunch of matrices in system services, and we have created, we started with the Prometheus and using the Grafana dashboard to see the matrix. What I'm going to show you is that we have a built-in system services dashboard that gives you insight about the matrices of all the system services that we have: operators, injector, CA sentry, and placement. So this gives you initial cutoff matrices, which is required to get an insight what's happening into the system. So the first and the foremost important thing is the health and resource of all the system services. So each panel in the Grafana dashboard, it gives you a view like from how long the system services are up. So you can see that we have all the system services running healthy from last 5.8 days. This is a cluster that we created, and we are using diagnostics to see here in the cluster. So the cluster is up from 5.8 days ago. So all such system services are running healthy. And we also give a view of matrix of total CPU usage for each system services to see if anything goes wrong in the system, what's the CPU usage. We can see how each service is running and how much CPU is being consumed. But similarly, for the resource perspective, we give the memory usage for all the system services. And this is the additional that we have number of go routines, which gives you extra insight about how the number of go routines spikes up or goes down with respect to each system services. So this first panel that we give is a health and resource of all system services. Next, we brings down the specific services. Like the next is operator, which for the initial set of matrices, we provide two panels, which is like number of services created into the operator. So for the current cluster that we have bunch of services created that we can see right now, there are 11 services has been created. And similarly, we have number of services deleted. So just before this meeting starts, I deleted one actor app. I can see that this was deleted on 10/42 on 17 March. And this way will give like how many services are deleted. Next, we have the panel dashboard for Injector surveys, which basically tells about the number of sidecar injection requests, the total number of sidecar injection requests, and out of those, we can see how many are successful. And the next panel that we have is CA Sentry surveys. And this is very important because many of the issues happen in the production. We see basically about the certificate expiry and the renewal time. So we have this very important tile which says about like how many days, how many time left for the cert expiry. If we say for the cluster that we have, it's like 51.3 weeks left. This is very important for the ops to see that what's the remaining time. And these are the certificate signing requests from the Dapr runtime. You can see the CSR request and the success rate and the success. And if at all any failure happens, we can see a different panel that we have, which will show the CSR failures. Right now, there is no failure, so we are not seeing any data. And this is something also like we have issued cert and key changes total, another interesting panel. And these are related to failures. We don't have failures, so there's no data, but in case we have, we'll see some here. Another panel that we have in the dashboard is placement surveys. In the placement surveys, it's like total number of replicas that are reporting their heartbeats to placement surveys. You can see these are the number of replicas. We have 11. And this is this panel is the panel that I'm right now highlighting is number of replicas that is not hosting actors. So in the cluster we have right now we have 11 which total replicas. Out of those 10 are not hosting actors, and this gives you a count of when you want to know that how many replicas in the cluster that are not hosting actors. And this is the number of actor types we have in the system. Right now I have the only actor app, and which have only one, so we see just one. So with that, we have, this is the initial set of matrices that we see that we think that is important. So we created this built-in dashboard and using Grafana and Prometheus, and all the setup instructions like how to set up dashboard and the whole exported dashboard, which is available. The instructions are available here in our Dapr repo, which lists out all the instruction how to set up Prometheus and Grafana, and how to do all the configuration, how to add the data source for Prometheus. Basically list out everything. The dashboard is available as an exported JSON. Just go to the Grafana, set up the data source, and just import the dashboard, and you will see all the matrices in the system services just right in front of you. So that's all from my side. I will now hand it over to Youngbu. He will cover the sidecar dashboards. Thanks, Yaron, and thanks everybody.
No problem. Go ahead, Youngbu.
Okay. I cannot share my screen. Shalab, can you turn off the sharing?
Sure.
Okay, let me share my screen now. So I'm gonna show the Dapr sidecar dashboard. When you're using the Dapr, so you are probably asked some questions like, my Dapr sidecar is running correctly. All the components is initialized. Is this problem with my app, or is it problem with the sidecar? This dashboard shows this dashboard helps you to understand those kind of the questions. So if you look at this dashboard, so basically you can filter two things, namespace and app ID. If you're interested in, you can select the apps that you are interested in. So basically for now, I would like to select the two apps here. For example, the Node apps and a Python app in the Hello Kubernetes sample. So if you selected two apps, then it will show the status of the sidecar of these apps. So the first section, you can see the uptime of the Dapr sidecar. Again, but this dashboard is solely focused on the Dapr sidecar, not the user side metrics. We are just focusing on the Dapr sidecar. So you can see how long these sidecars is running, and you can figure out that if there's some issues, and then sidecar can be restored, and you can figure out the issue here. So the next panel shows the resource usage. These usage exactly same as what the Shalav explained it before in system dashboard. So you can see the CPU usage and then the number of Go routines and memory usage used by Dapr sidecar. So if you deployed multiple replicas for the apps, then you can see the cumulative memory usage and CPU usage. And the next section, it shows the latency of the throughput for the HTTP channel. So as you know, the Dapr supports two channels, HTTP and gRPC. So this chart shows the request latency between the user app and Dapr sidecar. So this one is very similar to the metrics of the service mesh, but we are just focusing on between the user app and Dapr sidecar traffic. So if you look at this chart, so this one is outbound request latency, which means when the user app calls to the Dapr app, then it will show some request latency. But request latency means the turnaround latency. So basically, if you look at this, so Python apps calls the Node apps, and then Python apps use this API to call the Node app, invoke Node app method. This latency includes all around turnaround the latency. For example, let's take a look at that. So the Python app calls the Dapr sidecar for Python app. So, and then Dapr sidecar calls to Dapr sidecar for the Node app. And then Node app, this sidecar will call Node app, and Node app will store the state to the state store. And then once I save the state to the state store, it will return value. So this latency, it includes all the around call flow's latency. So we can say this latency is a turnaround latency. For this particular the calls, it is latency when the Node app save the states to the state store. So we can see if we are using the multiple state store or multiple secret store, then you can see the performance of each state store or secret stores. So, and this one is the request rate. The request rate for the request from the user app to Dapr. And also this one shows the inbound request latency. That means the latency when Dapr sidecar calls the user app. So through this, you can see the performance of your apps endpoints. This one is the request latency. So, and then the next panel shows the same chart, but it's for the gRPC channel. The next component panel is for the components that you configure for the apps. So for example, when you configure, let's say you are configuring the two components. For example, Redis state store and Redis pops up. So, and then when the Dapperized app is deployed to your cluster, Dapr sidecar will try to download the components configuration from the operator, and then Dapr sidecar will try to initialize these components. So for some reason, for example, for some reason, the initialization could be failed. For example, operator set the wrong secrets to connect to Redis, then the initialization will be failed. Then you can see the number less than loaded component configuration. And then if there's any failures, then you can see the reason of the failures of component initialization. So then you can easily figure out what the problem is. So if you try to deploy like 100 apps to your cluster, it is really difficult to find the issues just through the logs. You need to figure out, you need to search the logs manually. It's hard to figure out what apps has a problem with the specific components. This dashboard shows the problems and the failures and status of the loaded components as well. And next panel shows actor status. So in the sidecar, so you can see the actor activation status and in deactivation status, and also whenever Dapr sidecar rebalance the table, then it always talk to the placement services, and then if there's something wrong in the placement service, it will show some failures here. You can see some OKs, but if there's some issues, let's say, let me change the time range here, like 7 days. So if there's we have some issues when we redeploy the Dapr. So there's some downtime in the placement service, and then we have some issues here, the failure issues like this. You can easily figure out what the problem is for the actor. And then we will improve this dashboard. We will add more metrics related to like a timer and reminder and turn-based concurrency in the 0.6.0 release. The next section is the last section is for the MTLS. So basically when the Dapr is started, it will try to get the root search to initialize MTLS, and then also it tried to get the workload search from Sentry CA. So you can see that if there's any failure, you can see some failure initialization status, and then you can see the failure region as well. And then also workload search, based by default, it will be rotated every 24 hours. So you can see when the workload search is rotated here. If there's any failures, then you can see some failures and then failure region here. And that's all I have. And also, as Shalav explains, so if you go to the questions. What? I cannot see.
Are you trying to post a link in for where to find us? I'll post it in the chat window. There's a link for how to set this all up. Yes.
Yep.
Yeah, let's post it in the chat window, and we'll do it that way. But it's in the docs effectively how to set up your Grafana dashboard for your applications.
Yep. Okay.
Okay. Thanks, Youngbu. Fantastic. We've gone past time. We more than we thought we could. So I think at this point, I will just saying we're working on the 6.0 the 6.0 release, the 0.6 release, I should say, which is going to come out. We're targeting beginning of April. For you can go into the GitHub repo. You can go and look under. You'll see there that there's a 6.0 milestone. Feel free to put some comments on things that you see and post it to us in the GitHub chat room, or actually even just upvote things inside the repos themselves, or just drop us drop a question or anything inside the GitHub repo into you'd like to see. So with that, we're out of time for questions. Sorry we don't have too many time for questions today. We probably have a couple of them if people want to ask them. We'll be here in 2 weeks' time. So posted updated dates inside the Dapr community page. And so the next date now is on the 31st of March, to the last day of March, and then we'll have one on the 14th of April and 28th of April. So probably on the 31st of March, I'll probably give you an update of where we are with the 6.0. So any last questions that you want to ask? Your mic and ask questions. Or if not, asking us questions on GitHub, and thank you for all your contribution. Thank you for your time. We appreciate it greatly. We're hearing all your feedback. Thanks.